Joining everybody. Welcome to this session on Power BI and FHIR. I'll be talking about a few other things in this presentation about how you can use your data that's in a FHIR service already to create some interesting analytics from it. But I'll be focused mainly on Power BI and how we built Power BI connectors. So this will go from high-level stuff to progressively more in the weeds with the language and so on. But I hope I can take you with me on that journey. So I'm gonna just say that this presentation is kind of the second half of what I did yesterday. Yesterday I talked a little bit about how to set up a FHIR server and create applications and get some data into it. And now we're gonna talk about consuming this data for creating analytics. But you could think of them as going together. So if you didn't catch that one yesterday, go check that out. Also on this link that's on the slide here is a link. It actually goes to a GitHub repo where there are PDFs of my presentation, both from yesterday and today. And there's quite a few slides in there, and most of them I will not show here in this presentation, but there are actually screenshots of all the things that I do as I go through what is mostly a demo here as we get into it. So you'll be able to do it yourself. So they're mostly there in case you want to walk through the steps yourself. But I might not show those slides here, but you can go grab them there. There's also a Jupyter notebook that I'll be showing in a little bit here in this presentation. So that's the context. So let's dive into it. What I'm going to start from is an environment that we have, which is sort of a sandbox that you can go and spin up yourself. It's available on GitHub at this address here at the bottom of the slide. You can go and provision this sandbox, and you will get something that looks something like this. It has a mechanism for bringing in data into the FHIR service. You could dump some Cynthia bundles in there. They will get ingested. And then we talked about that yesterday, and smart on FHIR apps and so on. I'll give you a very, very brief tour of this. But what I'll focus on is really what you can do with the data once it's in here. The first thing I'll show is how to actually export it into a storage account and hook up something like Databricks to do analytics on that, which is going to be a little bit in the weeds too. And then I will then take a step back from that and then talk about how you can do it in a simpler graphical way using Power BI. So we'll walk through those different things. And then after that, we'll talk a little bit about how we made this Power BI connector. But I'm going to switch over now and basically do most of the rest of this as just a live demo. So I'm going to start in the Azure Portal here, where I've provisioned a bunch of things yesterday, and most of them we will not touch on, but this samples environment or sandbox environment is in here. You can see I have a FHIR server in here where I've put some data in, and then I have a few other components here, but one thing is a storage account labeled export here, and that's when it's paired with the FHIR server. So if I go in and call $export on my FHIR API, this is where the data will show up. And that's what we're going to start with here. So I'm going to bring up Postman and just show how this is done. So here is the FHIR service. I've set up an environment here in Postman already that's connected to this. I can just browse the patients here. I've already gotten a token ahead of the presentation here. And then I can simply go now and call $export on this. So we support system-wide, and we're working on patient and group-wide. Group-wise exports too, but this follows the spec here. You provide the prefer header and so on, and then you simply hit export. And what you will get back then is a content location. So you get this header back with where the status of this export job is. And if I hurry here and grab this URL, I should be able to see that it's not done yet, and you just still get a 202 accepted, but then in a few seconds when this is done exporting, we'll actually get a list of all the files that have been exported. But if we look here at this GUID here that gets generated, that is the GUID of the export job. So it's 597B3 something. If I go now into my environment, into the storage account here, I should be able to find a container with that name here. So it's B97, this one here that is just being created right now. And if I click in here, we can now see that all the resources are being exported from the FHIR server in ND-JSON format, where you can then pick them up and work with these resources. I've also done this quite a few times, as you can see, to test this out. And so I'm just going to work off one of the containers that are already exported and try to do some analytics on that. And what I've done as well is that I have spun up a notebook in Databricks. So you can see I've provisioned a little Databricks instance here, and I've opened up a Jupyter notebook inside this instance here, where I can interact with this data. And what I've done is I've simply connected to one of these storage containers here and mounted this data. And then I create some temporary tables. I'm not going to do this again because they're already created here, where I'm pulling out all the observations and all the patients. And then we can start creating some virtual views here, or temporary views. So I'm getting all the heights of the patients, I'm getting all the weights of the patients, but I'm also getting things out of the extensions here with my Spark SQL, like latitude and longitude I'm pulling out here of the patient resources. And then I can start joining all of this data together. And this shouldn't take very long, since I don't have that much data in this FHIR server. But you can see now that I've taken the data that is within the FHIR service, and I have relatively easily exported it into a storage account, and then I can just provision a service like Databricks, and I can really start going exploring in here. I can train models, I can do all sorts of things with my FHIR data. But this is a bit in the weeds technically, right? I have to be able to work with these Jupyter notebooks, work with this data, create SQL queries, and so on. So it might not be the easiest place to start if you just want to create some visualization of your data. And so to make this whole process a little bit easier, we have created a connector for Power BI that natively understands FHIR. So I'm going to demo this, and if any of you saw Doc 7's presentation earlier in the week, you will have seen some of this already. I'm going to walk through it again in a slightly different way, but talk about a few other things. And then afterwards, we're going to talk about how we actually made this connector, which might be interesting for this audience. So what I've opened up here is Power BI Desktop. This is a free application that you can just go download. And if you go download the latest version of Power BI Desktop, it now comes with this Power BI connector built in. And Power BI is really made up is a place where you can bring together multiple data sources, and you do it with these connectors. So where you simply go and say, I want to get data from a different data source, and we're going to hit more here to get to all the different types of connectors that are available within Power BI. And you can see there's a ton of them. SQL servers and all sorts of other different kinds of data sources that you can connect to. And this is actually part of the real strength of this kind of tool. Is you may have some business information in a SQL server, you may have some stuff in blob storage, and now you may also have some stuff in a FHIR server, and you want to bring all of this together and create a dashboard and a visualization of this data. So to do this, you would simply type in FHIR here, and we can now see that we have a first-party FHIR connector. It shows up here. You recognize the flame logo. And then you hit connect, and you'll then be asked to supply a URL for your FHIR server. And I had one already in here. So I'm going to grab the URL of my FHIR server here and go and paste this into Power BI. I'm going to remove the metadata part of that. So what will happen now is, if this was the first time I connected to this FHIR server, I would have been asked to authenticate, but I've already connected a few times to make sure that that everything was working. So what the connector now does is it actually goes to the capability statement of the FHIR server, and we figure out a few things. First of all, we figure out which version of FHIR it is. This connector right now supports DSTU2, STU3, and R4. And based on that, we now know what schema to apply as this data comes in. But then we also look at the capability statement and figure out what resources are available in this particular FHIR server. So if it's a FHIR server that only has observation and patient, these are the only things that would show up in here. But I'm going to decide on what data I want to work with. So I'm going to grab some allergy information, allergy intolerance information, and I should probably also get the patient resource to go with this. So you simply click the resources that you're interested in working with, and when you've clicked the ones that you want, you hit transform data. And what this brings you to is a Power Query editor. This is actually a graphical editor where you can write queries in this language called M, which is what Power Query works with. this language is available in a number of different Microsoft tools, Excel, Power Apps, and so on. But here we're using it in Power BI. And what we'll notice here as this comes up is that we're completely aware of the full FHIR specification, even for all the fields where there may be no information. In this case here, identifier is null for all of them. But we know there is an identifier there because what we're looking at here is just a preview. It's just the first few rows of what comes in. And so suppose those resources didn't have that particular field. I still want to be aware that it could be there so that I can expand it and on it and work with it. And then you can go and pull out various information here. So for instance, I probably want to know something about what type of allergy this is. And instead of pulling out all these fields, I'm just going to pull out the code text. This is Cynthia data, so this should be pretty consistent, but you may want to actually pull out the code and have the label separately, but we're sort of cheating a little bit here. But you can see as I try to expand these, for instance, I want to figure out what patients these belong to. I know what fields could be in this reference, and I want to pull out only the reference field. So for every single field, column, everything, we're completely aware of everything that could be in the FHIR specification. And so this is actually a great way to just learn and explore and play with it and learn something about FHIR and the specification without necessarily needing to go to Postman. So that was a little bit on the allergy information here. I probably want a little bit more information about these patients, and I could pull out something like the address, right? It's also another field where I have lots of different fields in here. Many of them may be empty for this particular file server, but I can just decide what I want here. So let's say I just want the state and the zip code, and I will expand those out. And as we walk through this and edit these different queries, we're actually building up queries here in this M language. You can open up this advanced editor, and we're going to dive into this language quite a bit a little bit later on in this presentation. But actually, what's happening here is you're clicking and selecting and filtering and so on. But it really just turns into these expressions in this language called M, which we then evaluate and send back to the file server. And so, for instance, one key feature of this connector is that if you were to put selections in there and say, I want only patients with a birth date after a certain time or something like that, we would actually turn around, recognize what FHIR search parameters that corresponds to, and send it to the file server. And we'll dive into in a second how that actually works. But once you're done with all of this, you simply hit apply and close. And what now happens is that we will go and refresh this data from the file server. This shouldn't take very long. In this particular case, I just have a few patients. But of course, this could take a while if you have thousands and thousands of patients, which is also why your selections, it's important that they get passed on onto the file server. So I'm going to quickly create some graphs with this, or some plots with this data here. And I'm not actually a Power BI expert, so if there are some of those listening here, my apologies. I will try to do my best. But I'm going to put in some values here. I want to look at the specific allergies and how they're distributed. And now I want to tie it to the patients. And to do that, you probably want to make sure that you've established the right relationships between your resources here. So there are some fields that we automatically generate for each entry here, which we sort of give some brackets on here. These are synthetic fields. We generate a reference ID, which is kind of like the primary key for this resource. But I could take, for instance, here, allergy intolerance, and tie it to the patient reference here and tie it up here. And I can, for instance, control the properties of this relationship. And let's say I wanted this to be bidirectional. But you can now see I've tied the patient reference field to the reference ID field here on the patient resource. And then we can go back and work more with our data. I might want to put in a map, for instance, here, and figure out where these patients are located. And so I think I pulled out the zip code here, so I'm going to put this in. And what we should see now is that these guys are all in Massachusetts, since this was generated with the standard settings on Cynthia, right? So you can now not only can you see where all these patients are located, But you could actually now start drilling in and saying, well, these guys with allergy to bee venom, where are they located? Or the shellfish, oh, this was mold, and here's shellfish allergy. Shellfish thing may be a New England thing. But you can see how we now have very interactive, rich plotting of the stuff that's in the FHIR server with just a few clicks and working with the data. And it really comes from understanding the specification and being able to drill down and make sure all these fields are labeled appropriately. I also wanted to show you that this is not just for the Microsoft FHIR server. We can actually access any FHIR server. We do have some restrictions regarding what types of identity providers we support. So right now we support Azure Active Directory, but if you wanted to, if you're interested in other identity providers and what we should support there, please let us know. But I'm going to pick another FHIR server. I'm going to say I'm going to do the Vonk FHIR server here, for instance. And I think this is their standard R4 endpoint, but we also support Stu3 and R4. There may be a lot of people trying to access this FHIR server right now, so we'll see how this goes. But I could, again, let's say I wanted to work with the patients here. Let's try to figure out where the patients in the Vonk FHIR server and the public Vonk FHIR server are located. So we could go here, name, birth date. Let's see here. I am trying to locate the address. There we go. And I may want to just say country and state and zip code. I'm going to load this in, and I'm just going to save this real quick. So I don't know exactly how many patients they have in this in the public Vonk FHIR server or how much load is on it, but hopefully this should only take like a couple of minutes to pull back the data and bring it into the into the workspace here, where I can then start to work with it. So I could create a new page here and another map, for instance, and put in the patients from the Vonk FHIR server. I'm hoping that we'll see here that these patients are now all over the world, which is actually what we see here. So we have all the patients in the Vonk FHIR server. I was suspecting that there would be more here in the Netherlands in this server, but I can see that there's quite a few here as well. So I hope you get the impression here that you can really connect to any FHIR server using this and start getting insights from your data very quickly with just a few clicks. So that's the basics of how it works. It's a very quick demo of that. But I wanted to talk a little bit more, especially to this audience, which might appreciate it, about how we actually made this connector and what our plans are for it going forward. So I'm gonna skip to that, and what I actually did here now was I skipped over screenshots of every single thing that I just did, so that you can go and do it yourself. And now we get into this M language that the Power Query connector is built on. And so what we decided to do here, because there's so much information in the FHIR specification, that rather than handcraft this M code that goes and applies schemas and so on, we actually wrote some code generation tools instead. So what we do is we take these code generation tools and we parse the FHIR specification, and then we generate really two main categories of things. We generate the schemas that we apply. So when the data comes in, we will apply a schema onto this data so that we know this is a date, this is an address, or this is a text field, and so on, so that we're aware of all the different types. So that's one part of it. We generate that. And then the other is what we call folding patterns or query folding patterns. And what that is, it's really critical to making this work efficiently. What that means is that when you make selective queries in the Power Query editor, we will turn that into FHIR searches and send them onto the FHIR server. And this may sound obvious, but this is actually a non-trivial problem, because in FHIR, we don't write our filtering expressions directly based on the names of fields in the resources. So it's not like OData or something where you can compose your search query if you know the names of the fields. You actually need to know what these search parameters are, what FHIR path expressions they correspond to, and so on. And so that's what we generate, is these patterns that we recognize and turn into specific search queries. And I'll walk you through what that looks like. But before we can really get there, we need to understand this M language. So this will be your crash course in M, the Power Query language. So just some things you will see. Lists are in curly braces like this. Records, which are like equivalent to objects, are these sort of named fields in square brackets. So it's exactly like JSON, but only opposite, just to make it a little bit more confusing. We have table types that have table column headers, right? And then they have specific rows in here. And then we have things like functions that you can describe, defined this way. And then this is a lazily evaluated language, which consists of typically these sort of let expressions where we define different terms and selections and so on. And then we have an output down here. And these assignments here are immutable, and they only get evaluated as needed. And it's very powerful when you have big data sets like this, that you can write these queries, and then depending on how you end up selecting down, you only end up selecting part of it. So you end up with these types of expressions here where you start with the data source. Here we use the FHIR connector, go to a specific FHIR endpoint, and then we sort of continuously expand things. This was actually what I just did with the allergy intolerance. I expanded the code text and the patient reference, and then I returned this table, and these things will get evaluated. So we only go in and apply schemas and things on the things that we extract. The rest we don't need to do, so it makes it quite efficient. What now becomes important here with FHIR is this concept of query folding. And just to make it a little bit more clear what I mean about this, suppose now we wanted to get data from a specific FHIR server here, and I wanted to take the patient table, so all the patients, but I'm not going to filter the rows by saying I'm only going to select the rows in this patient table where the birth date is less than something. We now need to send this onto the FHIR server for this to work efficiently, right? If these are the only patients we're interested in, we don't actually want all the other ones coming back and then filtering it in the client. That would be a waste of bandwidth and put additional load on the server. But what we want to do is we want this query to go to the FHIR server, and when that comes back, we will then apply schemas and so on. And this is the process of query folding. And as I mentioned before, this is complicated in FHIR because we cannot, here it's fairly easy to determine from this field that we're searching here that this should maybe turn into birth date as the search parameter, but that's not a given. There are many different instances where not only searching a specific field doesn't map to a search parameter of the same name, but actually if you filter on multiple fields at the same time, it maps to a specific search parameter, and these can get very complicated for composite search parameters and so on, and I'll get into what we do. So what we actually do is we generate a bunch of patterns, and then we take these expressions that come in here, we look at these expressions, we reformat them a little bit into a form where we would recognize them, and then if they correspond to a specific search parameter in FHIR, we will pass that search parameter onto the FHIR server. And then other filtering expressions on things where there are no search parameters, we will do those filterings in the client, right? So we have this two-stage filtering that happens. So what I'm going to do to show you a bunch of examples of this is I'm actually going to pull up a little environment that we have set up here. So this is a sort of a repo environment where I can flip through various different expressions. So on top, what you see on top here is you see the M expression, and what you see down below is what it turns into in a FHIR search. So here I'm working on activity definition, and I'm looking for a specific description, and it turns into this query parameter down here. Now, this may look a little bit crazy if you're not used to working with M. So what's actually happening here is that this would be equivalent of a sort of lambda expression like this. So you can see when I save this, it updates the query down here below. So you might be more familiar with recognizing it in this form, but in M, they have this shorthand for it, which is each. And actually, it's supposed to look like this. There's supposed to be an underscore here representing the X from the lambda before, but you can also leave that out as a little bit of extra sugar here. So it looks a little unfamiliar when we look at it first, but these are some of the shorthands that are commonly used in M. So what we're going to do here is we're going to very quickly march through a bunch of these different folding patterns and slowly get into the weeds as this gets more and more complicated here. So you're going to have to bear with me as I walk through this. So here's something very simple, right? We're searching for a string, but there are important things here. Like when you say equal to in M, it actually needs to be exact in FHIR, because we don't mean this thing here, right? Where we're saying the description starts with, which would be the equivalent search in FHIR. So we have to recognize these things, and these are patterns that we pick up. Things like contain, we'll recognize too and add those onto it. And by the way, if your FHIR server doesn't support one of these modifiers and returns an error as a consequence of us sending that query, we will back off and come back with the query without that filtering parameter, and then we will let Power BI do the filtering for you. So we always fall back on that. So even if your FHIR server doesn't have that capability, it should still work. So there are things like searching for a number. It's pretty straightforward. Greater than, of course, we recognize that and turn that into the right search. We also recognize it in the sort of Yoda form. If you switched it around, we'll rewrite that and recognize it, and it still stays the same. We support ands, we support ors, which are also commonly used in FHIR. So all of these patterns would get recognized and turned into FHIR searches that we pass on. Then we have things like these tokens here. So things like male, so gender equal to male, but it may also be not male. It's also very important, and we will pass that on to the FHIR server. Boolean fields, right? I want all the active patients. You can write that in a number of different ways. You could say active has to be equal to true or equal to false, but you can also just say each active, and we will, interpret that as a Boolean expression, recognize it, and pass it on as a FHIR search. And similarly, you could say not, and then we would also recognize that and turn it into a false and send that on. So there are many different variations of these terms, right, that need to be recognized, and that's why we generate all these different patterns from the FHIR specification. Then it gets a little bit more interesting here. Now we get into coding fields. So the simple one is just, I'm looking for all the encounters here where the class has a certain code field. So that would turn into that class search down there. But I might provide a system as well for this. So we have to recognize that I'm actually now putting two criterion in my M search or my M selection, but that again falls to a single search parameter in FHIR. And then there are there's ones with no system on it, and also something where it is not a specific system and code. So we recognize those. Here's the or expression as well that would turn into that same not expression there. And then there are cases where we filter. In M we can filter on two fields independently, but it cannot fold to a single search parameter. So we make some semi-heuristic decisions about picking the most selective one. We will pass that search criteria on with the search query, and then when it comes back to the client, we will filter the rest in the client. So you will get this combination of on the server and in the client filtering. Here is something that we can't fold. There is no way that we could turn this into a search expression that would go onto the server, but it will still filter in the client. It just means that there may be more data coming back. So it's worth thinking about these expressions in them and whether or not they will fold to a search parameter. Quantities are also very interesting, right? You can filter on the value, but you may also have a system and a code to go with this. I'm going to maybe take the zoom down a little bit as these get progressively more complex, these expressions here. And then we have something interesting, which is choice types in FHIR, right? So we have fields in FHIR, for instance, observation value, that can take on a number of different types. And what we do with that is that when we apply the schema, when the data comes back, what we will actually do is we will create a record for instance, for value here. Record will have a number of different fields for each of the types that it could possibly have. And then when you filter on it, we will then recognize that is actually what happens, and we will then use, in this case, the value date search parameter. It could also be a period, in which case it also is the value date search parameter, but we apply the filtering expression here slightly differently, right? So we recognize all of these and send them down to the server. For values, they can also, here's a example of a string, right? And it's an exact value. And then there are types in FHIR where there are arrays of complex types, right? So think about address and patient, or in this case, I've used the meta security field. And in there, we could have a number of different entries of these complex types. So now we use these M expressions where we say we're looking for a record that has in this table, which the security tag becomes, that any row matches this particular system or system encode, right? We pass that on to the security search parameter here. We could also, it could be, we could have AND expressions in here that we will also recognize and pass on. And there are also lists of primitive types. So for instance, in this case here, it is profile, so it's a URI. Because this is a URI, we can also use the above or the below and above and so on. All of these things again get recognized, turned into specific modifiers and passed on to the search. All of these little things is really what makes this Power Query connector work efficiently, even against very, very large data sets, as long as you put some selective queries on. So we also recognize missing fields, right? So if I say that gender has to be null, we will turn that into a missing. So nulls are very interesting. We can hold a whole lecture on that. But we recognize all the different types here that you can have and support that. In places where we have many of these, right? So in this case, we're saying we need a resource that has a security tag set, right? So that's important. Or something where there is no security tag, we will recognize that as well and get that passed on. And another example here with the with missing security tags. So now we get into something a little bit more interesting, into codable concepts. And so here I am looking. So code encoding is an array on observation here. And so what I'm looking for is a specific observation that has a certain system encode. So we're going to slowly ease into this here because this is going to get a little bit complicated. I can actually search for other things in there. I could search for the display parameter of code. And there's a different way to search for the specific code text, which would be this expression as well. And we, of course, can do both of them at the same time, which will then fold into an OR on the same search parameter. So you can start seeing that this is not completely trivial. And so there are many different permutations of these patterns. And it's really only by generating them from the specification that we can be allowed to do this efficiently. So taking this and for those of you who are starting to think this is really going off the rails here, we're almost at the end here. I just want to show that how we deal with composite search parameters, which are also very important. So for instance, let's say we wanted to look for observations, right? So observations, here in this case, we're saying I want to look for the systolic blood pressure at less than 90. So I could write a query like this, but it is actually not quite what we want, because I'm looking in component of observation here, and I'm saying I need an observation that could have this specific code, and also where something in component has a specific value, has a value less than 90. But we're not necessarily enforcing that this code and this value have to be together, right? So it turns into this AND expression down here, but it's actually not totally what we want. So what I really want is something like this. I'm going into to the component, and then for each of the components, I'm looking for one where the coding has the specific code and the value is below a certain value at the same time. And this now maps to a composite search parameter, right? So we know this is a component code value quantity search parameter. This is a very unique feature of FHIR, that we have these search parameters that there is really no way to know from just looking at the fields that I'm filtering that this is what the search parameter would be called. I can only know that by looking it up in the specification and see what's been defined in there. But we recognize these patterns and send them onto the FHIR server. Now, of course, you can OR these together, right? If you had more of them. And you can also, there's something interesting, for instance, about observation, where you can either search for a value in a code that's at the root of the resource. So in this case, I'm looking for a height measurement defined at the root of the resource with a value above 150. So that's a code value quantity search. But it could also be in the component instead. Let's say I had recorded height together with weight or something like that. Then it could be in the component. So now I have a component code value quantity, but it could be in either, right? So I may want to search for both of them. And I promise this is the last one here of these, and then I'll take some questions. But it could be in both of them. And we will recognize that because there is actually a search parameter for that as well. So now you can either be at the root of the resource looking for a specific value, or you could be in a component of the observation resource. And we recognize that that particular pattern is actually the combo code value quantity search parameter, and we will send that onto the FHIR server. So even sort of fairly sophisticated things, we get rewritten and recognized and then pass those onto the FHIR server. So it's quite a few examples here, and I have captured a lot of them in the slides. And we also have a documentation page, and I'm going to try and pull up my last slide here. So again, so I've captured all of those patterns and things that I walked through here in the slides that you can download. You can also download the samples environment that I use to connect to here with Power BI. And we also have a docs page for Power Query itself. And if you go to that docs page, there is a section now for FHIR, and there's a whole tutorial on this query folding, what search expressions are particularly selective, how you should write this, good ways, good practices for ordering things, and so on. If you want to work seriously with Power BI and FHIR, it's worth taking a look at that, because you can really improve the efficiency of your queries by taking advantage of the things that we've built into the connector. And finally, if you need a free Azure subscription, there's a link there. There's also my email address. You're welcome to reach out and give feedback and suggestions. And otherwise, I just want to say thank you for your attention and take any questions that you guys might have. Last 2 minutes here.
Sure. Thank you, Michael. So this is Rick. I'm the moderator. There's looking at the questions that have been posted so far. There's one, and it is: does the integration support the below, above, in, and not in modifiers for code typed fields? So these are modifiers in the FHIR search API. For instance, in would let you say is a particular value in a value set or not.
Yeah. So I would say not all of them, but we support quite a bit of it. But they fall into the category of also so we will likely generate the correct folded query, but whether or not a FHIR server supports it is a different matter, right? So what we do is if we recognize it as one of those patterns, we will fold in, we will send off that search query. But if you get an error back from the FHIR server saying we don't support that, we will back off and then come back with the query without that selection criteria on. But then when the data then comes into the FHIR server, Power BI does not understand your value sets and all that and know how to filter that. So it's not supported within Power BI. But if your FHIR server recognizes that query and does the filtering correctly, it would work.
Okay. Okay. So if it doesn't, then you need to, for instance, write some special code to enumerate everything in the value set expansion and work.
So if you were to do that in Power BI, what you would do is you would query your value set or whatever it is separately, right? Bring that into a separate table, and then you would write what's called a DAX expression or something in Power BI to do that filtering in there. But that could get complex depending on what it is.
Got it. Okay. All right. I don't see any other questions. I'll give folks a second. Oh, here we go. Another one just came up. Do you think Power BI is better than the FHIR dashboard that Microsoft created with the FHIR API?
So the FHIR dashboard, are we talking about just the like the patient, little toy patient viewer we have or something? If if that's the question, so Power BI is a lot more powerful. I think you can do tons of different things with it, lots of visualization tools, many third-party visualization tools, and this ability to bring FHIR data and other data sources together is pretty unique. So that you can, because often not all of the information that you want to visualize in a dashboard, it may not be in your FHIR server, right? So this ability to pull patient data together with, say, demographic data or other types of data is very appealing. So it's a different thing. Yeah.
Yep. Okay. Next, there's one that just popped up that says, would you be better off using this over querying a data lake?
Yeah, so I think it depends, right? So that's why I showed in the beginning that you could, chuck all your resources into a data lake and you can spin up something like Databricks and work with it there. I think that is very powerful, right? You can do a lot of things. You have access to everything, all different tools. You can train models and so on. So I think that has use as well. But I think Power BI very much appeals to users that are maybe not super deep in writing Spark SQL or other expressions like that. So I think you can get off the ground very quickly with your FHIR data without having deep knowledge of writing code and so on. So I think they might appeal to slightly different audiences and different types of analysis. I think there's a place for both.
Okay, good. Well, if there's no other questions, I've got one of my own. So this is from me. Many public health use cases require searching across patients. For example, find all patients with COVID-19 with a COVID-19 diagnosis. Most EHRs today don't support searching across patients. In other words, they assume a single patient context, like a smartphone app that a patient would have to get only their data. Does Power BI deal with this in any way?
Yeah, so we actually ran into this a little bit. So as we were making this connector, we made it very generically, right? We were not targeting a specific FHIR server, not ours in general. We were just kind of following the specification. And then I thought, well, let me go to a couple of the sandboxes, the Epic and the Cerner sandboxes, and just try this out. You very quickly hit a roadblock because they sort of force you to have what I think, do they call it strong demographic searches or something? You have to restrict yourself to, if not a single patient, then a few patients. And so the Power BI doesn't really explicitly deal with that, right? We would be subject to the same restrictions.
Right.
But you could write some stuff in Power Query that iterates through a bunch of things, a bunch of patients, right, and brings them in. I'm not quite sure how.
Correct. Yeah.
Or what other restrictions they might put on, but those EMR FHIR APIs tend to be very restrictive when it comes to looking across the population.
Right. Okay. Yep. Just wanted to see if you found something that I that I didn't.
No.
Okay. Well, thank you very much. Let me see if there's just do a quick refresh. I don't see any more questions, so I think you can just wrap it up. Or Dave, if you want to give any closing.
Thank you. Thank you, Rick. Thank you, Michael. That's it for today. So enjoy the rest of your day.
Okay. Thank you.
All right. Thank you. Bye-bye.